Hi everyone, my name is Bryan Vadheim. I'm an economist at Vivid Economics, which is an environmental economics consulting firm based out of London. I spend most of my time thinking about natural resources, so agriculture, forestry, water, that sort of thing. Typically, the projects that I work on are for governments or multilateral institutions, like the World Bank, UN agencies, or development institutions like USAID. I also spend a bit of my time in the private sector, thinking about low carbon transition problems and strategy for corporations, as well as for investors as they try and get a grasp on what a sustainable future might look like. And I'm here to talk to you today a bit about economics and its role in a sustainable future. I'm going to start with a pretty common idea, that the world has a climate problem. I suspect that everybody listening to this presentation has heard that before, and if they haven't heard it before, they have certainly heard it in the past 2 days of conference presentations. So I'm an economist, and so I'm going to be a bit pedantic and read you some of these quotes. Emissions resulting from human activities are substantially increasing the atmospheric concentrations of the greenhouse gases. This will result in an increase of global mean temperature in the range of 1.5 to 4.5 degrees Celsius. Therefore, industrialized countries should adapt their own economies in line with future agreements to limit emissions. The quotes in the second column look pretty similar. Perhaps they're even more stark. So human influence on the climate system is really clear. Continued emission of greenhouse gases will cause further warming, increasing the likelihood of severe, pervasive, and irreversible impacts for people and ecosystems. Limiting that climate change would require substantial and sustained reductions in greenhouse gas emissions. Why am I reading you this slide? Because they're quotes, and they're quotes from 30 years ago. The first column is from the IPCC assessment report from 1990, and the second column is from the fifth version of that same publication in 2014. I am not cherry picking here. The Intergovernmental Panel on Climate Change, the IPCC, the world's leading convention of scientists on climate change, have been saying the same thing for 30 years. I could have picked any of the 5 different currently published assessment reports, or I would be willing to bet any of the headlines from the IPCC assessment report number 6, which is coming out in 2022, and we would have come to the same conclusion, that we have known about climate change for decades. The science has been clear for decades. The impacts have been clear for decades, and what we need to do. So adapting our own economies requires substantial and sustained reductions in greenhouse gas emissions. That has also been clear for decades. And yet, somehow we haven't done anything about it. This graphic is one that will be familiar to most of you, I suspect, as well. It's annual carbon dioxide emissions associated with the burning of fossil fuels for energy and for cement production. You'll see that since the publication of Assessment Report 1 in 1990, that pink dashed line, things haven't gotten that much better. CO2 emissions certainly haven't gone down, and in fact, they've continued to rise at as fast or faster as the previous 40 years. And so we are now up to 35 billion tons of carbon dioxide emissions every single year. So I want to reframe our previous statement that the world has a climate problem. Sure, of course that's true. The world does have a climate problem. But maybe a more actionable statement is that the world has a climate communications problem. Now, how we've tried to deal with this in the past is by making statements like I've put below. Surely if more people knew, that would solve the problem. That would result in governments, in individuals, in companies doing something about climate change and reducing their emissions. If we had more or better or clearer evidence. That's the classic scientists approach of we need more research in order to be able to say, and surely once we have that research, we can demonstrate unequivocally that this is a problem on a massive scale, and that will motivate action. Another approach that we've taken before is if we translate this into tangible impacts on the ecosystem. So make it really clear, carbon dioxide emissions, that's pretty abstract and hard for people to see, but people can see polar bears and tree frogs and things like that. So maybe if we illustrate perhaps through pictures the impact on polar bears. I'm sure that all of you have seen some version of the picture below of polar bears standing on melting ice caps as a way to make people care about climate change. The problem is that it hasn't worked. If it had worked, I would not have been able to show you the carbon emissions graph and it continuing to rise that I just showed you a slide or two ago. So I'm an economist and I like to make gross simplifications. But what the conclusion that I draw from the fact that the world has known about climate change, its consequences, and what to do about it for the past 30 years is that people know, and for some reason they do not care. Now, I want to convince you that you do not have to care about science, you don't have to care about the environment, and you don't even have to care about polar bears or tree frogs in order to care about climate. The corollary of this is that if you care about polar bears and tree frogs, which I certainly do, then it can be beneficial to assume that your audience does not. I want to give you a few examples of climate communications that might motivate action that do not rely on any of those previous assumptions. Now, I don't want to pick too much on climate scientists or the NGOs that make and rely on what I'm calling the polar bears and tree frogs arguments. I think that those are, first of all, 100% true. They are secondly really important, and they do make more people aware of this issue, which I think is really important. And so I don't want to sell them short. However, I do want to talk today about 3 arguments for climate action that, in my view, are massively underutilized. Now, I'm going to be incredibly reductive in assuming that people exclusively care about their self-interest. They want to make money and what is in their interest, and that is it. So 3 arguments to work on that work on those sociopaths. First, that ignoring climate is going to cost you money. Secondly, and humans are very jealous creatures, and the only thing worse than it costing you money is that it means that somebody else is going to make money instead of you. And the third argument, particularly applicable for governments, is that climate investments are better for the wider economy. So let me start with the first, that ignoring climate is going to cost you money. And don't worry, I want to make sure the best way to illustrate all 3 of these arguments is with examples. And so I'm going to bring along examples. Now, where better to start than energy? The energy sector is one of the biggest in the world. It comes in at $6 trillion in annual turnover. This graph is another very common and familiar one, the global primary energy consumption by source. So it looks at all of the world's energy and breaks it up into where it comes from. You'll see traditional biomass there in red along the bottoms, or along the bottom. So that's mostly wood. You can see that humans have been using wood to create energy for quite some time, since well before this graph starts in 1800. You'll see fossil fuels in gray, blue, and purple, respectively, so coal, oil, and gas. And then at the very tip top, you will see other renewables. So solar there in yellow makes up something like 1% of our total energy consumption today. Now, I want to pick on coal, which will probably not surprise any of you. But before I pick on coal, I want to talk to you about renewables. Now, there's a lot going on this graphic, which is one that I've borrowed from ARENA, which is one of the global leading sources on energy systems. And so each of these columns, these 4 columns, onshore wind, solar photovoltaics, offshore wind, and concentrating solar power, which is, I don't know if any of you have seen those big towers with the mirrored arrays that concentrate sunlight into a particular point in order to generate electricity. So these are 4 different types of renewable energy projects. Now, all of the dots that you see, those are individual projects from around the world. And the y-axis on the left is the cost per kilowatt hour associated with that project. And so the lines that you see, the orange and blue lines, those are averages from around the world. And again, you can see there on the bottom that timelines associated with all of these. So in general, almost all of this is clearest to see in the solar PV column, the second column, but this is true of all of them, is that they start there on the left at relatively high cost, and then that's in 2010, roughly a decade or so ago. And then by 2020, so just last year, those costs are a lot cheaper. These, by the way, are unsubsidized. So the subsidies have been, to the extent that they exist in whatever market, those have been accounted for. And what you're seeing is the unsubsidized cost associated with renewable energy sources. Now, the green band on across each of these graphics that runs from about $0.6 or $0.06 or 6 cents per kilowatt hour up all the way to roughly 16 cents per kilowatt hour. That is more or less the range associated with fossil fuels. So if you were to build a new fossil fuel plant today, that would be towards the top end of that range in terms of cost per kilowatt hour. If you were to build a brand new, or excuse me, if you were to operate an existing coal-fired power plant, so you don't have to pay for any of the infrastructure costs associated with building it, the operating costs are down towards the bottom of that range, roughly 6 cents per kilowatt hour. The costs associated with fossil fuels are relatively similar around the world. Of course, I'm massively oversimplifying, and any expert in the coal sector will tell you that things certainly do vary by regulation within the country, by how close your coal source is, by how good that coal source is, all of those sorts of things. But in general, fossil fuel plants fall within that green band. Now, why am I showing you this graphic? It is because renewables have gotten massively cheaper over the past 10 years. And many of them, like solar, they've started being competitive, unsubsidized, with fossil fuel sources of electricity just in the past 5 years. And that means a massive change is on the horizon. And nobody thinks that renewables are done getting cheaper, right? So many people, many energy experts, expect that by 2025 or so, the cost of solar might be as low as 1 or 2 cents a kilowatt hour. In some of the sunniest places of the world right now, there are competitive, unsubsidized auctions in which solar photovoltaics are providing energy at 2 cents a kilowatt hour or 3 cents a kilowatt hour, or roughly half the lowest operating cost of fossil fuels. So what does that mean? That means that pretty soon building renewables will be cheaper than operating coal. Now let that sink in for a moment. You can build a brand new solar photovoltaic plant very soon for less money than it would cost you to keep a coal-fired power plant that is already built and that you already have running. That's wild. Now, what are the implications of that? The obvious implication is that that's pretty bad news for the coal sector and its investors. The graph on the left that you see is a snapshot of a commodity index, the US Coal Commodity Index, from between October of 2014 and September, the end of September of 2015, in which the coal price dropped something like 80% from its previous average, which had been, of course, like all commodity markets, fluctuates up and down, but has been relatively consistent over the previous stretch. So that 80% drop in coal prices is that happens to coincide with when onshore wind and solar started to get competitive with the more expensive fossil fuel plants. Now, of course, there's like many factors here. In addition to the rise of renewables, there's also natural gas that started competing with coal, and to a variety of different things. And so I'm not saying that renewables are the one killer of coal, but they are a contributor. Now, all of those companies that you see on the right-hand side, all of them are bankrupt. And all of them went bankrupt in roughly a 3 to 4 year stretch, around starting in, I think, 2012 out to 2016 or so, because many of these companies had taken out big loans on coal-fired power plants and the infrastructure associated with them. So the shipping bays associated with coal, the mines associated with coal, all of those things. Now, if you were an investor in one of these companies, you lost a lot of money. That means that loans and investments made to fund coal right now, in general, they're bad investments. There's a really high risk of default. So if you care about, you do not, again, the point here is you do not have to care about climate. If you are an investor who cares about money, you need to stop being in coal. That brings me to the second argument that I want to spend a bit of time on and bring you an example of. Ignoring climate means someone else gets to make money. Now, I won't belabor this too much, but I want to bring you an example of forestry here. So any climate scenario that comes anywhere close to 2 degrees Celsius, which is the target associated with Paris Climate Accords, is to keep the world at or below 2 degrees of global average temperature warming. Any of those scenarios need to massively expand forested areas. We're talking hundreds of millions of hectares. Just to give you a sense of scale, the Amazon rainforest, the entire Amazon rainforest, is something like 550 million hectares. And it depends on exactly what scenario and exactly what temperature you're getting to. But any of the scenarios that the IPCC has published, they have a lot of forestry, on the order of anywhere between half an Amazon to 2 Amazons worth of reforestation and ecosystem restoration over the next 30 to 50 years. Now, and the reason for that, of course, is because tropical rainforests in particular, but natural ecosystems in general, are incredibly carbon dense. And so cutting them down in the first place has contributed quite a lot to greenhouse gases globally already, and emissions generally. And so reforesting and restoring those habitats can be an important factor in reducing emissions and pulling carbon dioxide out of the air. So now, all of this is predicated on the world actually doing something about climate change. But if it does, all of that land area that needs to be restored, somebody needs to restore it. Now, forest finance, to the extent that it has existed before, has historically been pretty small and largely the purview of the public sector. But the policies associated with ecosystem recovery and those sorts of things, they've already started to emerge. And so we can see examples of this where in the voluntary carbon offsets market, where companies are starting to make money by restoring forested areas. And if provided that continues, which the expectation, if the world is going to meet its Paris agreements, the expectation is that it will. So if that does happen, we're talking about a market that is absolutely massive. It is something like 7.7 trillion with a T dollars out to 2050. Now, of course, we said earlier that the energy sector is $6 trillion annually, but still 7.7 trillion over the next 30 years is nothing to sneeze at. That is a lot of money to be made in reforesting the world. Here again, the point is you do not have to care about forests. You do not have to love tree frogs. If you want to make money, there's an opportunity to do that. Finally, this brings me to the third argument that I think is underutilized, and that's that climate investments are better for the economy. Now, this is a bit of work that we did recently on simulating COVID-19 stimulus packages that included environmental restoration investments instead of building traditional infrastructure. Now, everybody will be very familiar, given the recent debates in DC about stimulus packages. What most people know about stimulus packages is that some of them have involved checks to people. Now, that's not the spending that I'm talking about. So that sort of spending, along with bailouts to the restaurant industry or the airline industry, that's also not what I'm talking about. There's a portion of that stimulus package that includes investments. And some of those investments around the world have tended to favor traditional infrastructure. So rebuilding roads, rebuilding bridges, all of those sorts of things. Now, all of those things are, of course, really important, and I don't want to, as an economist, I love infrastructure, and I don't want to knock the roads and bridges argument as being important for the economy. However, one of the things that we looked at, and one of the things that we were able to demonstrate with some economic modeling, is that scenarios that stimulus packages that involve some nature-based solutions. So things like, in nature-based solutions, the acronym for that is, of course, NBS, which is why you will see that on the graphic currently on the screen. Now, nature-based solutions, those are basically environmental restoration investments. They are forest restoration, they are peatland and wetland restoration, those sorts of things. Now, those have the benefit of being really labor intensive. That means that you don't need to source a bunch of steel, you don't need to source concrete or something like that. Some of those supply chains end up overseas. So we import quite a lot of our steel, for example, from China or from other countries around the world. And so stimulus packages that make big investments in traditional infrastructure that rely on steel, some of that money ends up going via trade routes over to the companies that make the steel in China or other parts of the world. So being labor intensive means that those jobs stay domestic, which is something that's really popular with national lawmakers. Now, that means that nature-based solutions investments in environmental restoration can actually do better in terms of job creation, in terms of creating economic value, all of the sorts of things that we care about when we're implementing stimulus packages. So the takeaway here is that even if you don't care about environmental outcomes, even if you do not give a rip about biodiversity or carbon storage or any of those sorts of things, restoration projects associated with stimulus can outperform conventional alternatives. That's all there is to it. Now, I've been talking too long, so I want to wrap up with just a plea, I guess. Of course, scientific and environmental messaging is really important, but it's not enough. There are really powerful economic arguments, and I hope that I've demonstrated this to you over the past 20 minutes or so. That there are really powerful economic arguments that exist in order to motivate climate action across a wide array of topics. I picked a handful of examples, but I could talk for some time about others. Ultimately, climate communications is going to require a mix of approaches. And so any of you who are thinking of undertaking some sort of climate advocacy, whether that's you want to lobby someone in the government, whether you want to encourage action within the companies that you will be working for, whether that is you want to make sure that the scientific research that you're doing is impactful and useful to policymakers, I would please encourage you to consider economic arguments as a tool in your arsenal in order to drive that point home. I have found them to be really effective, and I think that they're massively underutilized. I really appreciate your attention. It's been really nice to talk to you today, and I look forward to any questions that you have during the panel. Thank you very much.